I'm Daniel Levine, and this is the Bio Report. The DDR pathway plays a critical role in repairing DNA damage in healthy cells that would otherwise cause mutations or cell death. When this pathway is altered and becomes unable to repair this damage, mutated cells can grow out of control and become cancerous. They can also be more resistant to standard chemotherapies and radiation. Aprea Therapeutics is developing therapies to target mutations in genes along this pathway to treat certain cancers. We spoke to Oren Gilad, president and CEO of Aprea, about the DDR pathway, the use of so-called synthetic lethality to treat these cancers, and why Aprea's approach may result in safer and more targeted therapies. Oren, thanks for joining us.
Thank you for inviting me and for sharing Aprea with your audience.
We're going to talk about synthetic lethality, Aprea Therapeutics, and its efforts to develop therapies that work in a precise way to exploit a weakness in cancer cells to kill them. Let's start with DNA damage response pathways. Can you explain what these are, their normal function, and what happens to them in the case of cancer?
Happy to do so. The normal function of DDR is to detect and repair damaged DNA and to maintain the integrity of the genome. It also prevents accumulation of mutations that lead to oncogenesis because it is fixing the damage before cell division, before the cell divide. In terms of cancer, this function, DDR, could lead to introduction of mutations on the DNA, which then drives cancer mutations like RAS, P53. Those are just two examples. And another point to note is that in cancer, one of the first things that happen is that cells start to grow out of control and to create replication stress and accelerate cell division.
You're developing therapies that focus on synthetic lethality. Can you explain what that term means?
Happy to, yes. So the way we think about it is that cancer cell that is replicating out of control is like a car speeding down the road. And the drug is the roadblock at the bottom of the hill. So cancer cell having specific genetic mutation, the drug inhibits the function of a vital pathway that the cancer relies on to survive. So if we summarize it, then cancer cells lose one function, and then we inhibit another one that it needs to survive. And that's the synthetic lethal interaction.
What's the case for pursuing synthetic lethality as a therapeutic approach in cancer? What advantages might it provide?
Cancer cells have replication stress while normal cells, when they divide under normal control, have minimal effect. Because under normal conditions, cells is not, for example, enter S phase if this environment is not ready. But cancer cell is pushing the gas and removing the brake. So by matching the disease with the therapy, one can maximize the effect and minimize the toxicity. And there is one well-known example, and that is PARP inhibition in cancer with BRCA, BRCA loss of function. That's already been approved and on the market.
Well, what determines whether a particular cancer might be good for this type of an approach?
I can use examples from two of our clinical programs, the WEE1 and the ATR. So WEE1 and ATR protecting cancer cells from accumulating damage and death. Cancer cells that are under replication stress rely heavily on ATR and WEE1. And when you take it away from them, they are accumulating damage in the form of replication for collapse, and then they die. So this is the realization of personalized medicine.
There are a number of companies pursuing synthetic lethality strategies. Where does Aprea fit into the greater set of companies, and does it think it has any technological advantages over others in this area?
Yeah, that's a good question. Aprea's focus is on one critical pathway with multiple targets that are in synthetic lethality, targeting the DNA damage and response pathway. It's a very focused pipeline, a very focused set of research. And we focus also on developing selective assets. You can find other inhibitors that are dual inhibitors. Our belief is that you want to have a selective compound, and that's also been translated very nicely into the clinic. So we also choose programs that can work as single agent, monotherapy, and in combination with other agents, including our own portfolio. One example that we shared in the past is that you can combine ATR and WEE1 because they're synergistic. And by doing so, you can actually reduce the dose of each by half and maintain the efficacy.
You had been the CEO of Awry Pharmaceuticals, which Aprea acquired in 2022. You became CEO of the combined company. What was the rationale for the transaction, and what was in it for each company?
Yeah, so Aprea, before the acquisition of Awry, had the p53 reactivator. And Awry had an ATR, WEE1, and a platform. So the rationale for the transaction was to form a strong company with multiple high-quality assets, yet maintain the focus of synthetic lethality, targeting the DNA damage and response pathway. So by doing so, on the Aprea side, Aprea de-risked the pipeline because they moved from a binary event to now having multiple shots on goal. And then Aprea and Awry, from the Awry perspective, we got an immediate access to capital to advance our programs. And ever since the acquisition, we were able to get the ATR into the clinic, and it's now in dose escalation. We got the WEE1 through IND and into the clinic as well.
The company's lead candidate is ATRN 119. What is that, and how does it work?
ATRN 119 is a small molecule. It's actually the first microcyclic ATR inhibitor to get to human. It is used to target cancers undergoing replication stress. And as for the MOA, ATR responds to the formation of single-strand DNA, and that's taking place in S phase. And we actually published a paper back in 2010 talking about how ATR can be looked at as target for cancer therapy. And for your audience, they can also go on our website and look at some publications and some posters that we posted and shared at conferences. All in all, there are certain genetic mutations that lead to reliance on ATR activity that, when inhibited, can lead to selective cell death, cancer cell death.
This is in development for advanced solid tumors. How are you narrowing in on indications you'll pursue?
That's where our Replibiome comes into play. That's our platform. So our platform, Replibiome, is complementary to, I'm sure most of your audience familiar with CRISPR. CRISPR is a platform, it's a great platform that is looking at really genetics, and you knock down gene. So when we looked at CRISPR, we identified one limitation for this assay. And that is, when you knock down an essential gene, you're likely to kill the cell because it's an essential gene. So how do you solve this problem? Because once the cell is dead, it's impossible to get any information on it. So you solve it by going proteomics. And that is where our platform, Replibiome, comes in. Our platform is focused on proteomics analysis. We're looking at everything that's coming on and off the replication fork, and it's helping us in different ways. One is patient selection. Where do you get the widest therapeutic index? By really matching the drug with specific genetic mutations. The second thing it is helping us is also enriching the pipeline. And undisclosed is one example of it. And the third thing is it could provide some insight to resistancy. How does cancer cell may develop resistancy to a treatment? And by understanding that mechanism of resistancy, it is helping us identify targets that we can go and target in patients to prevent the resistancy.
Have you identified what cancers you'll initially pursue?
Yes, we did identify, and they are, we're not disclosing at this point, but it's going to be implemented into the expansion phase of the study.
How might this compare to other ATR inhibitors in development?
I think that the most noticeable feature is the preferred safety profile that is allowed for daily dosing. And this is important because cancer, in order for the tumor to grow, cancer has to replicate, right? Cells have to replicate, which means that the DNA has to duplicate. And that's where ATR is active. So if you have a drug that is putting constant pressure every day on the target ATR, it is for benefit. And you can do it when the drug is well tolerated. And we're also not seeing hematological toxicities. So really potentially can have the ATR in 119 as the preferred inhibitor for combination therapies, because you don't want to treat patients with two drugs that are having overlapping toxicities.
And what's known about the therapy from the preclinical studies that have been done to date?
That it is a very safe molecule with anti-tumor activity. It's also, we showed that it is working as single agent and in combination with other agents.
As you think about the development strategy, what's the path forward?
Right now, we're looking at QD, but we also disclosed that we are going to explore BID. And it's really coming based on data that we're getting from the clinic and from patients that is helping us developing the path of development moving forward. So BID is definitely another approach that we would like to explore.
You mentioned you're looking at it both as a potential monotherapy or in combination. Is there something that it's well suited to be combined with? Is there something that might be synergistic?
Yes, that's a great question because it really comes to the mechanism of action of ATR. So ATR can be, because of the mechanism of action, it can be combined with radiopharmaceutical, it can be combined with ADCs, with chemotherapy, with PARP, and other targeted agents that we are definitely will explore in the future.
You also have another candidate in development. This is APR 1051. This is a WEE1 inhibitor for ovarian and other cancers. How does 1051 work?
So 1051, as you mentioned, it's a WEE1 inhibitor, and WEE1 is active in controlling cells moving from G1 to S. It's a very critical point, but also from G2 to M, right before the cell division and entering into mitosis. And under certain conditions, like cyclin E overexpression, there is heavily reliance on WEE1 to be fully active. So when you have the cyclin E overexpression, putting pressure and reliance on WEE1, and then you're inhibiting the WEE1 activity, that's where we see a synergy, and that's where the synthetic lethality is.
What's the development path forward for that, and where are you at this point with it?
So it is in the clinic, and we said that we're going to get into the clinic second quarter, and we did. It is now in the first phase of the dose escalation, and this is accelerated titration. Once we complete the accelerated titration, the plan is to move on with a boring design, which is a 3+3 dose escalation.
And how's the company funded to date? How much cash do you have right now, and how are you thinking about raising additional capital?
So the cash on hand is into the fourth quarter of 2015. Back in March, we did a very successful financing where we raised $16 million upfront and potential another $18 million with 2 half warrants. We're always looking for, obviously, every biotech company is always thinking about the next financing. And so are we. There's potential for next financing alongside activity, some clinical activity and response, as well as others. And I think that for your audience, I think that maybe it would be it's interest for them to know that this can be a good potential investment opportunity. We have 3 analysts that are covering us, giving us a price range of $14 to $20 as price target. And the stock is being traded at a heavy discount at this point. So this can be potential investment opportunity.
Oren Gilad, President and CEO of Aprea. Oren, thanks so much for your time today.
Thank you.
Thanks for listening. The Bio Report is a production of the Levine Media Group. To automatically download this podcast each week, subscribe to our RSS feed or through iTunes or other podcast manager. To join our mailing list, go to levinemediagroup.com. We'd love to hear from you. If you want to drop us a line or are interested in sponsoring this podcast, send an email to danny@levinemediagroup.com. Special thanks to Jonah Levine, who composed our theme music, and the Jonah Levine Collective, which performs it.